Now it's time to take a look at playing with loops. And so I'm going to start a new project here. We did one for decisions before, probably watched that. But I'm going to go ahead and open up a new Java project. And now we'll call it loops, just to kind of give you a feel for how we create these things. So again, I could call it loops, hit finish. Oops, it's showing the outline here. Oh, you know what I did? I closed the wrong thing here. So let me show you how to recover that while we're here. File, show view, project right here, Project Explorer. And that brings my stuff back. I accidentally hit the close button on that instead of there. So my decisions project's still there. Here's my loops project I just created. There's no code in my loops project here, so I'm going to create a new Java class. And this can be loopy. Our start of our project, and like we did last time, we can type main control space and have it generate our main method for us. So loops, we saw the basic counting loop in the lecture materials, assuming you looked over that. So for a for loop, I can show you that same type of thing. Int, we have an index variable. The index variable keeps track of the position that you're walking through. Think of it as kind of like your lap counter if you're going to go running. That's your index variable. You can do a mile. A mile is 4 laps of the track. So you try 1, 2, 3, 4 for each lap you have going on inside of there. So this, you typically call it index I. I can call it count. You can call it lap. Let's just say lap here. Is equal to, we'll start with 1 this time. Why? Because we can. Typically they start with 0 because Java arrays and other data structures use 0, but we can start with 1. We can start whatever we want to. You know what? Let's get crazy. Let's start with 4. And so while, nope, I'm sorry, not while, lap is greater than 0. So we're going to count down and we'll say lap minus minus right there. So we're going to do 4 laps and start. So we'll do a system dot sys dot out dot. You know, I'm going to use control space print line here. My typing has gone bad since the last time. And I'll say we are on lap. Sorry. Let's say laps to go right there, and then plus lap. So this plus right here is not doing addition, it's doing appending. We're taking the string laps to go and we're pending on this variable lap that we called here. And so let's see what this does. Let's see if our code works the way we expect it to. So laps to go 4, 3, 2, 1. We start with some number of laps and we count down from there. So this is the counter example to what you saw in the prior lecture materials where we counted 1 to 10 just to show we can count down just as easily. There's a lot of variations here you could do. You could say lap is equal to lap, sorry, can't type, minus 1. That code works just the same if you don't like that minus minus structure. The only time I use the plus plus and minus minus, and minus minus is very rare, would be in a for loop like this. I traditionally like to see this, but contextually it is okay to have it coded like this here because it is condensed. It's very, very close and very, very easy. So I can go through here and say some sort of check of Boolean I'm tired is equal to false. So we could say while the laps is greater than 0, so there's still laps left to do if you want to do more than the number of laps you've chosen, and we'll do a double and. Okay, the double and is what's called a shortcut and. I'll explain that here in just a second. But and not the exclamation point right here. You can call it bang or exclamation point. I'm tired. So while there's still laps to do and I'm not tired is what we can read there, that I'm going to keep running here. And so you can say 4, 3, 2, 1. All right, I could combine my logic inside of here and say if lap is equal to 2. So for some reason, when there's 2 laps left to go, I always get tired. I'm tired is equal to true. All right, so we can combine the things we talked about. We talked about if then else statements before we talk about that logic. And so if the lap gets a 2, I'm tired. That would change the way my code works right here. So you can see I go lap 4, lap 3, lap 2, and once I hit lap 2, I don't do lap 1 because I'm tired, because that's what I just said here. So if lap is greater than 0 and as long as I'm not tired, then I'll keep looping. But in this case, I made myself tired through the 3 laps I did, and so I quit. Okay, I stopped running early. So the for loop is not finalized. It's not everything there. This is kind of one way of structuring the logic. We'll come back to that here in a second. The alternative loop to the for loop is the while loop. I could say while not I'm tired, and work it the exact opposite way. So right here, let's just say I'm tired is equal to false. So you go back to not being tired, because we set ourselves to be tired right here. And so we're going to start by setting ourselves as being not tired right here. So while I'm not tired, I could say system.out.println run a lap. All right? And if I ran this code, oh my gosh, I'm still running. I never get tired, so I'm still running. Oh crap! Here, my program stopped. How do I? It's still working. Look, it's still. How do I stop it? Well, if you get this situation, if you create a loop accidentally that runs forever, go up to the Run menu, and go to the. Oops, sorry. Apologize. I'm thinking NetBeans right there. In NetBeans, you go to the Run menu and you hit Stop. In Eclipse, there's a Terminate button right here. You just hit that Terminate button and it stops the program. Now, if I look back, I've been running laps for a really, really long time. By default, Eclipse only keeps the last several hundred lines, so you can actually tell it to keep every line it produced inside the run, so you could go back to the beginning, but it just printed that a whole lot. And that was, again, this little Terminate button right here. It was lit up red when it was running. That's how I stopped the program if it run away with it. So my problem here is I need some way to get tired. So what I can do is I can count my laps. Int counter is equal to 0. I start with 0, and then I can say counter equal counter plus 1. And if counter is greater than or equal to, let's say 20 laps out there, I'm tired is equal to true. Okay, so we again can integrate the if then else structure inside of our loop, and in this case we absolutely must go off and do this. I have to have something that's going to update this condition at which I'm looking. So when I run this now, you can see laps to go 4, 3, 2, and then I run some laps. Well, how many laps did I run? Well, I can actually go through and say plus plus counter, and I can print that out and see how many laps are run. And so I ran lap 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 19. So I actually ran 20 laps instead of there, starting with number 0. And then I got tired and I stopped. So there's the two basic structures of the loop. We saw up here, we have an index variable created as part of it. We have that condition that comes up and resolves to a Boolean, and then I have a lap countdown. In this case, I had just a criteria. I had to create my own index variable of sorts. I had to create my own condition at which I was going to stop doing it. By changing the state of that variable. So it just keeps going as long as that thing's true. Often you'll use while loops for things like user input. I'll ask a user, give me a number, give me a name, give me a radio station, give me a book title. And until they give me something that's appropriate, that I deem as appropriate, I'll keep asking them the question. That's why I would do it. So the update is each time the user sends in new information, and my logic validates whether it's good or bad. We'll see that later on. We'll actually see some code that does that later on. But for now, this is the loop structure. Honestly, the do while loop is completely uninteresting here. I can bring this down to the bottom and throw the word do up top, and it compiles just the same. And let's just go check it out. And guess what? It runs just the same. Because it just ensures that it does it one time here. The main difference is if I say I'm tired is equal to true up here, in the previous way, we would not run any laps. In this way, we do run one lap. We always run one lap even if we're tired, just because that's the way the logic works, the do while versus the while. I want to point out the logic up here and the logic up here are very close to being the same. Whether I would do the while loop or the for loop, it doesn't really matter. In the top one, I knew I wanted to run 4 laps. In the bottom one, I wanted to run until I felt tired. It just so happened it was 20 laps. Probably what I would do is I'd have some sort of amount of energy in each lap. I would use some amount of energy, and until that energy was gone, I would know. But if I use the same amount of energy every time, I could calculate. If every lap cost me 1/20th of my energy, I know I'm going to do 20 laps, but three times I'm done. But maybe if one lap might cost 1/20th and one lap might cost 1/3 of my energy, depending on the speed I run it at or something like that. This is where this logic would come in. The last bit I want to show you before we go is the other thing I could have done here is instead of having the I'm tired logic here, I could simply have left that out. So I'm going to copy this. I'm going to bring it down here for one more example. I'm going to put a comment here. This is our break example. All right. Instead of having this I'm tired logic, I could have left that out, which simplifies my loop, which is a good thing, and say if the lap is equal to 2, I could break. Use that break command. So much like we saw in the switch statement, the break command leaves the loop, and so when I run it, I get 432, and the same logic down here, 432. It's just a way of you choosing to design. Neither one of them's right, neither one of them's wrong. This one could be a little bit cleaner, but there could be other conditions by which you'd get tired. So it may or may not be desirable to have a number of places where you break. I'm not trying to propose hey, this is the way you code this stuff. I want you to be open-minded to the fact there are alternatives. You might choose to do something slightly different than what's done here, and that probably is okay. I might give you feedback to say, hey, this other way is a little bit cleaner or the more standard way to do that. It's not to say you're wrong. It's just to say that different opinion, the different ways to get it done, and as long as it works in the end to some degree, it doesn't matter. But just so you understand that there is no one answer in solving code problems, which is why it's kind of hard to cheat as a coder, because there's always a fingerprint, there's always a digital signature, there's always a way that you figure out to solve problems. I'm not talking about like file signatures. I'm talking about the way you choose to code, the way you choose to organize logic. That's always distinctive to the person. It's a little bit different, and so own your style, figure out how you do things, but then also accept that there's different ways, there might be different feedback, and learn from that as well.